students, let's start and come over to question number 13, which has been asked in the paper. Question number 13 says that at very high pressures, the compressibility factor of 1 mole of a gaseous species is given by. That means he is referring to a very high pressure region. Now to solve this particular question, I'll ask you to first of all refer to the text which is given. That means he is talking about very high pressure region. Now in the very high pressure region, he is asking us to find out the compressibility factor, which is written as Z. Now we know that if I consider only and only ideal gas, then we can say that for an ideal gas, PV is equal to nRT, where P is pressure, V is volume, N is number of moles of the gaseous species, R is a universal gas constant, and T is the temperature. So we can say that Z is nothing but PV divided by nRT. And if I take N is equal to 1, we can say the volume will become equal to Vm, molar volume. So I can say Z is equal to PVM over RT. So this is the compressibility factor for an ideal gas. Whereas if I ask you to consider the van der Waals gas, then I can write P plus AN square over V square into V minus NB is equal to nRT. Now, if I have been asked to find out for 1 mole of the gaseous species, I can write P plus A by V square into V minus B is equal to R into T. Now we can say that if the pressure is very high, if the value of P is very high, then I can say that the second term, which is nothing but AN square by V square, will be a very small value. So I can say that P will be greater than A by V square, and hence P plus A by V square can be approximately written as P only. So our final equation becomes P into V minus B is equal to RT. On solving it, I can say PV minus P times B is equal to RT. So I can, if I ask you to divide the complete equation by RT, I'll get PV by RT minus PB by RT is equal to RT by RT. The equation simply comes out to be PV over RT is equal to RT over RT plus P into B divided by RT. That means Z becomes equal to 1 plus P times B over R times T. So this is the value of compressibility factor if the value of pressure is high enough. Let's see the options that have been given to us. So the first option is given to us as Z is equal to 1 plus P times B over RT, and hence I can say that this is the correct option for the question number 13. Now students, keeping in mind this answer for question number 13, let's move over to another question in this series, which is question number 14. Now question number 14th in the series state that, so question says that, so here this question is related to organic chemistry, where you have the Bovels-Planck reduction reaction involves. That means that is a name reaction, a name reduction reaction, and the options which are given to you are, first is the reduction of an N-hydride with LiAlH4. The second is reduction of an ester with sodium in the presence of ethanol. Third is reduction of an acyl halide with hydrogen in the presence of palladium, and the fourth is reduction of a carbonyl compound with sodium in the presence of mercury and HCl. Now dear students, this is nothing but a name reaction, and let me tell you that this name reaction, the reduction reaction, is nothing but the reduction of an ester to the primary alcohols. So for example, if I have an ester, let's say RCOOR-, if I try to reduce this ester in the presence of sodium and ETOH, or I can write C2H5OH. sodium in the presence of ethanol, or I can also write it as sodium in the presence of ETOH. Then this compound will get converted into RCH2OH. Also, this OR group will get converted into R-OH. That means you will be getting two primary alcohols in this case. And this reduction reaction is written so by the name mentioned in the question. So this is known as blank reduction. And hence, if I ask you to go through the options, let's see option number 1, 2, 3 and 4. So we need the option where it must be referred as sodium in the presence of ethanol. So the option number 2, you can see from the screen that the reduction of ester with sodium in the presence of ethanol. So ester being reduced by sodium in the presence of ETOH is the correct option for this particular question. Now students, done with question number 13th, it's a time that we should move over to question number 14th. So this was question number 14th actually. So let's move over to question number 15th now. So question number 15th, let me read it for you. The question says, what will occur if a block of copper metal is dropped in a beaker containing a solution of 1 molar ZnSO4? That means if you have a copper solid, a block of copper, and if you are dropping it in a solution which contains 1 molar zinc sulfate. So students, I think there won't be any reaction which will be possible in this case. Why is this so? Because in the chapter electrochemistry, you must have studied something about electrochemical series. Now, electrochemical series basically tells you like how the metals are gonna react with each other. Like out of copper and ZnSO4, we know that zinc has always the tendency to lose electron to form Zn2 positive and 2 electrons. Also I can say copper 2 plus has a tendency to react with 2 electrons to form copper. That means the most favorable couple will be Zn plus CuSO4 to form ZnSO4 plus Cu. Because I know that the reduction potential of zinc is less as compared to the reduction potential of copper, because the copper 2 plus has always got the tendency to get reduced as compared to the tendency for Zn2 plus to get reduced. Also I can say that zinc prefers to be there in Zn2 positive when copper has a tendency to get reduced to copper. But in this particular question you are asking me to go the other way around. That means you want that copper 0 should be reacting with ZnSO4 in plus 2 oxidation state to form copper 2 plus, and zinc should get reduced, which is not the favorable condition, and hence I should say that there won't be any reaction taking place in the above reaction. Let me look into the options. The option says that copper metal will dissolve with the evolution of hydrogen gas. That's a wrong option. Option number 2 is the copper metal will dissolve with evolution of oxygen gas. Again a wrong option. The third option is the copper metal will dissolve and zinc metal will be deposited. Again a wrong option. And the another option is no reaction will occur, and hence we can say that this is the correct option for this particular question, and hence coming over to option number 4. So students, this was about question number 15th. Now let us come over to question number 16th in this series. So coming over to question number 16th. And the question says that, so this is a kind of assertion reasoning question. The assertion is, rayon is a semi-synthetic polymer whose properties are better than natural cotton. And the reason is mechanical and aesthetic properties of cellulose can be improved by acetylation. So the first thing is rayon is a semi-synthetic polymer. And dear students, this is a correct statement because rayon is basically obtained as this is nothing but cellulose acetate. That means whenever you do the acetylation of cellulose, you will get rayon. So the reason referred here is correct one. Moreover, once we do the acetylation of cellulose, we can say that the properties will become better. Now the reasoning for this is mechanical and aesthetic properties of cellulose can be improved by acetylation. So let me read out the options for you. The option says both assertion and reason are correct, but the reason is not the correct explanation for assertion. Second is both assertion and reasons are incorrect. The third one is assertion is incorrect statement, but the reason is correct. And the fourth option says that both assertion and reasons are correct, which is the true case in this particular question. And the reason is the correct explanation for assertion. So just we'll be referring over to first and fourth option in detail. So the first option was rayon is semi-synthetic polymer whose properties are better. And second is mechanical and aesthetic properties of cellulose can be improved by acetylation. Since we can say both the statements are correct and the second is the correct reason for the first one, so we'll say option number 4 is the correct option for this particular question.